Hello again, Math 10Cs. In today's lesson, we're going to stop in terms of moving forward with like new content. And rather than moving forward, we're just going to look at the three different forms of a linear equation we've looked at over the last few classes and kind of play around with a few more examples that are related to them while we gain a bit more familiarity with the different forms of those equations and also like when they are most useful to use. So just as a quick summary to start things off, we've looked at three forms of an equation so far. So we have the general form of a linear equation. Now, the general form of a linear equation is the one where you have all of the terms collected on the same side. The coefficients in front of the x and y and the constant are all integers, so no fractions. And this equation doesn't really have like a whole lot of uses. Like I've said in previous lectures, it's mainly good if you want to figure out what the x and y intercepts of a graph are. But aside from that, like it's not very helpful when it comes to actually constructing a graph from scratch. The y equals mx plus b format is probably the most useful. So that's called the slope-intercept form. That's the most useful when you're trying to construct a graph, because you can plot the y-intercept, you can draw a slope triangle that represents the slope, and then you can connect a line between a couple of dots, and then you can form a straight line. We'll deal with that more in the next lesson when we practice on graphing these by hands. And then the other equation, which is the one that we introduced in the previous day's class, is the slope point form. And that equation is useful when you know the slope of a line and you know a single point that's on it. Okay, so let's go through a variety of examples where we can see how we can use these different equations. Okay, so the first one, it tells me that, okay, given point P is 3, -1, and point Q is -2, -6, determine the equation in general form of a line passing through the 2 points. Okay, so really the question to start off with right here is, based on the information given, what would be more like, what would be the easier equation to deal with, to start off with? Would it be the y equals mx plus b equation, or would it be the y minus y1 equals mx minus x1 equation? Now, regardless of whether we use y equals mx plus b or y minus y1 is mx minus x1, we're going to have to find the slope, okay? So as the first thing we're going to do here is we're going to figure out the slope based on these 2 points. So we'll call this coordinate x1, this coordinate y1. We'll call this coordinate x2, and we'll call this coordinate y2. So the slope from P to Q would be equal to y2 minus y1 divided by x2 subtract x1. Plug numbers into the equation. Y2 has a coordinate of -6. Subtract y1, which has a value of -1. Divide this by x2, which has a value of -2. Subtract x1, which has a value of 3. Okay, so -6 minus -1 would be -5. Divide by -2 minus 3 would be -5. And then -5 divided by -5 would just be 1. Therefore, your slope of PQ would just be equal to 1. Now, what we can do is we want to eventually get to an equation that's in general form. I think the equation that would be easier to start off with right here would be to use the slope point formula, because we now have the slope and we actually have 2 points. So we could actually use one of these 2 points to actually plug into the equation and attempt to get that general equation form. So let's start off by writing down the slope point formula. So the slope point formula is y minus y1 would be equal to m, and then we have x subtract x1. If we look up here, let's use this point, okay? Let's use the point 3, -1, although you could use the coordinates for point 2 as well, you just plug in y2 instead of y1 and x2 instead of x1. Either of those would work, okay? Because both those points are on the line. So let's put the numbers in here. So we'd have y minus y1 is subtract -1 would be equal to m, which has a value of just 1, multiply by x subtract, and the value of x1 is just +3. So let's clean this equation up a little bit. So y minus -1 would be y plus 1 is equal to, I'd say use the distributive property here, but you're just multiplying these terms by 1. So 1 multiplied by x would just be x, and then 1 multiplied by 3 would just be 3. So this would be y plus 1 is equal to x plus 3. We want to get this in general form, so it means we've got to move all terms over to the same side, but we want the term in front, we want the x term to be positive. So we're going to move the terms away from the left-hand side. So we're going to subtract y, and we're going to subtract 1 and subtract 1. Therefore, we would have x subtract y would be equal to, oh, made a little mistake here. It's funny. I was just saying like, oh, it's so easy just to multiply the 1 in by the 3. 1 times -3 would be -3, okay? So let's fix that. So this would actually be okay, yeah, -3. Maybe I should have actually written it like this first. Maybe I should have gone over to y plus 1 is equal to 1, and then x minus 3. We should have gotten rid of that set of brackets. Okay, and then this would just be x minus 3. Okay, now if we subtract this, it'd be x minus y, and then -3 minus 1 would be subtract 4. So you'd have x minus 1 minus 4 is equal to 0, and that's the equation in general form. Next one. It says determine the equation in general form. This is so unbelievably annoying. It seems like the only use that the general form has is to make us write the equations in it, even though like the equation itself is pretty much useless. Okay, so determine the equation in general form of a line that passes through the point 5, 0 and is perpendicular to the line to a line that has an equation of 3x minus 5y plus 17 equals 0. Okay, so what it's doing here is it's giving us a point on the line. So that's going to be x1, comma, y1. And we want to get an equation in the general form. Now, if I'm going to use the slope point form here, I need to figure out what the slope is. Okay, so what we're going to do is let's figure out the slope of this line. Okay, so we'll call this line L1. And figure out its slope, and then identify what a perpendicular slope would be. Okay, so let's start off with this equation, which is in general form. So you have 3x minus 5y plus 17 is equal to 0. And if we want the slope, we want to get it into y equals mx plus b form. So let's try to get the y by itself. Right now, the y is negative, so let's bring it over to the other side to make it positive. We're going to add 5y to both sides of the equation. So then this would give me 3x plus 17 is equal to 5y. And then isolate y. So divide both sides of the equation by a 5. The 5's cancel off. And then you get y would be equal to, okay, write the fraction. So it'd be 3x over 5 plus 17 over 5. Okay, so this slope would be y equals mx plus b. It would be 3 over 5. Now, we're trying to figure out the equation of a line that is perpendicular to this one. So we want to know the perpendicular slope. So that's going to be m perpendicular. Now, perpendicular slopes, when you multiply them together, they have to be equal to -1. The only way you can get that is if you take the negative reciprocal of the one slope. So the negative reciprocal of this would be -5 divided by 3. So the slope of a line segment that is perpendicular to line 1 would be -5/3. Okay, so for line 2, this is the line we're going to write the equation for. We know this. We know the slope is that perpendicular slope, which is -5/3. And we know it passes through the point 5, 0, okay, which is x1, y1. Now, let's write down this in slope point form. So, because now we have the slope and we have a point, so we'll go y minus y1 is equal to m, and then x subtract x1. Let's plug the numbers in. So the value of y1 is 0. The value of m is -5/3. And then here, you would have x subtract the value of x1, which is 5. Okay, let's clean this up a little bit. So I'll bring it over here. Okay, y minus 0, you may as well just write down y. And this would be equal to -5/3. And then it would just be x minus 5 in brackets. Now, the problem here is to get it in general form, we don't want to have any fractions. So what I want to do immediately is I want to get rid of this fraction. So we're going to put this entire equation in a set of brackets. And to get rid of this fraction, I'm going to multiply the entire equation by the lowest common denominator. But since there is only one denominator, that's going to be 3. So we're going to multiply by 3 by every term in the equation. So we'll multiply it by the y, we'll multiply it by this term as well. Okay, so that's going to look like 3 times y would be 3y, which would be equal to 3. And we're going to multiply by everything on the right-hand side of the equation. So we're going to multiply by -5/3, x minus 5. Now, if you do this correctly, something should cancel out immediately. So what I can see here is this 3 on the top and this 3 on the bottom, they just eliminate. Now, to continue to expand this here, what I'm going to do is I'm going to take this -5 and I'm going to multiply it by the x, and I'm going to multiply it by the -5 there. So that is going to give me, so we'll bring it down over here now. So I'd have 3y would be equal to -5x, and then -5 times -5 would be +25. And then general form, we want everything on the same side of the equation, but we want the x term to be positive. So we're going to add 5x to both sides of the equation, and we're going to subtract 25. Subtract 25, and then I would get 5x plus 3y, subtract 25, would be equal to 0. Okay, so that's the equation in general form. Okay, next page, just one more example. Okay, it says find the equation in, yes, of course, in general form, of the line perpendicular to the line 5x minus 7y minus 10 equals 0, and a line that has the same x-intercept as x minus 2y minus 12 equals 0. Okay, that's a little bit different. Okay, so we're interested in figuring out the equation of a line, which we're going to call L1. And this line we're going to write the equation for is going to be perpendicular to this line, L2, and it's going to have the same x-intercept as this line. So we're going to call that one L3. Okay, so the first thing I'm going to do here is, if we're going to use the slope point equation, then or even y equals mx plus b, I need to know the slope of our line we're going to write the equation for. So what I'm going to do is I'm going to calculate the slope of line 2, and then figure out what the perpendicular slope is, and then we'll know what the slope of line 1 is. So let's go to this. So we'll start off with line 2. So line 2 has an equation of 5x minus 7y minus 10 is equal to 0. I want to get into the form y equals mx plus b. So let's get the y positive, and I can do that by moving it to the other side. So I'll add 7y, and then I would have 5x minus 10 equals 7y. And then we're going to divide both sides of the equation by 7. Divide by 7. Okay, the 7s will cancel off here. And let's just rearrange it so we can put the y on the left-hand side. So I then have y would be equal to, let's write our fractions. So the first fraction would be 5x over 7. The second fraction would be minus 10 over 7. So what I know here is that the slope, because it's y equals mx plus b, would be 5 over 7. Now, our line L1 is going to be perpendicular to L2. So what we want is the perpendicular slope. So the perpendicular slope, M perpendicular, would just be, again, when you multiply together at this slope, it's got to be -1. And the only way to get that is if it's the negative reciprocal of that slope. So that'd be -7 divided by 5. Okay, so for line 1 here, we'll deal with this later, we know that our slope is going to be -7 over 5 because it's perpendicular to the slope of line 2. Now, it also says that it has the exact same x-intercept as line 3. Okay, this is like the one time where like the general equation is actually like useful. Okay, so let's write the general equation out for line 3. So we have x minus 2y minus 12 would be equal to 0. Now, if we're calculating an x-intercept, the x-intercept of a graph is when the value of y is equal to 0. So what we're going to do is in this equation, we're going to replace y with 0, which means that 2 times y would also be equal to 0. And then that's going to leave the equation as x minus 12 equals 0. To solve for x, just add 12 to both sides of the equation, add 12, and then I would have your x-intercept is equal to 12. Now, if we write that as an ordered pair, okay, in an ordered pair, the x-intercept would be 12, and an x-intercept is always going to be when y is equal to 0. So that's actually going to be, this x-intercept is actually going to be a point on line 1. Okay, so we're going to treat that as our point, and we're going to call that point x1, comma, y1. Okay, so now let's go to the line we're actually trying to write the equation for. So that's going to be line number 1. Okay, so let's start off with, so now what we have here is we have the slope, okay? The slope is -7 over 5, and we know our line passes through the point 12, 0. It has that x-intercept. So we can use the slope point form to write the equation and then get it into general form. So my slope point form is y minus y1 is equal to mx subtract x1. Let's plug numbers in here. Okay, the value of y1 is 0. So we're going to know y minus 0 would be equal to, the value of m would be -7 over 5. And then this would be x subtract, and what's the value of x1? The value of x1 is just going to be 12. Okay, let's clean this up a little bit by getting rid of that 0. So it would just be y would then be equal to -7 over 5, and then x minus 12. Now, to get it into the general form, we don't want fractions, so we got to get rid of that fraction. So again, what we'll do is we'll put the entire equation in its own set of brackets. And then to get rid of the fraction, we're going to multiply by the lowest common denominator. Because you only have one fraction, the lowest common denominator will be the value of that denominator. So that is 5. So we're going to multiply this part of the equation by 5 and this part of the equation by 5. Each term on each side by 5. Okay, so 5 times y would just be 5y. Again, that's not an x there, that's a multiplication sign. And this would be equal to 5. We're going to multiply that 5 by everything on the right-hand side of the equation. So negative 7 over 5, x minus 2. And once again, if you do this correctly, things should nicely cancel off. So the 5 on the top and the 5 on the bottom would just cancel. So they are now gone. Okay, so now all we have to do is on the right-hand side, use the distributive property. We'll multiply that negative 7 by x and that negative 7 by 12. So this will then turn into 5y would be equal to negative 7 times x is negative 7x. Negative 7 times negative 12 would be positive 84. And now to get it in the general form, we got to move terms all over to the same side, but I want my x term to be positive. So I'm going to have to move x to the other side to make it positive. So we're going to add 7x, add 7x. We're going to subtract 84. We're going to subtract 84. Okay, and then this would be 7x plus 5y minus 84 is equal to 0. All right, so that is the equation in general form. Okay, so that's it for this lesson. Just a short one. Again, like we're really just trying to like stop, pause a little bit. Well, I shouldn't say pause because we're still doing work. We're just not doing any new material. And once again, you can do questions numbers 1 through 6. And then in the next lesson, we're going to focus on how do we graph these things by hand. And I'll talk to you then.